sharing the screen.
Recording has started. You can start with the class.
Ma'am, please give me screen sharing permission, ma'am. Ma'am, shall I start?
Yeah, please start. Please start.
Good afternoon, Shalja ma'am. So I am ma'am today, and I'm working in China Public School as a physics faculty for a school. I would like to introduce new lesson today. So before introducing that lesson, I would like to ask you questions. Okay, suppose if we close our eyes, can we see anything? If we are closing our eyes, can we see anything? We cannot see anything. We are not able to see anything. So if we open our eyes, then we are seeing the world around it, around us, what all is there, the colorful world we are able to see. Okay, so there is a very close relation between light and our eyes. Okay, so when light enters our eyes, then only we are able to see the things around us. So today we are going to start the lesson regarding light. Actually, it is not light, but what are the properties of light? In that properties, one of the property we are going to discuss today. Okay, so before discussing the light, let me tell what are the properties of light. So you can see on the screen what are the properties of light. It is rectilinear propagation, reflection, refraction, diffraction, and polarization. Okay, so rectilinear propagation means light always travels in a straight line. Reflection is bouncing back of light rays. So these two properties you already learned in your earlier classes. When your previous classes you learned already. And diffraction and polarization, these two in higher studies you're going to learn like in intermediate. Okay, so the thing what we are going to learn now is refraction. Now in this 10th standard you're going to learn refraction, children. Okay, so refraction again in this chapter, in this topic, you have two types of refractions, that is on plane mirrors and curved surfaces. Okay, so today what we are going to discuss is refraction on plane surfaces, children. Okay, refraction of light on plane surfaces. This is the lesson, the title of the lesson. So before introducing this lesson, let me show you a small activity so that you will understand what's the phenomena. Okay. So you all can see here I have a glass of water. A glass of water. Water is there in this. Inside you can see the water. And this is the pencil. So you all can see the pencil is straight. Always pencil will be straight only. So I'm dropping the pencil here. So can you see a cut here? Here. Can you see a cut? So you are seeing a cut here so that it is like bent from there. It is bent. Actually straight. But when we are dropping inside, it is cut. Okay. So why this is happening? We are going to discuss. So first you keep that in mind. So I have a lemon. Okay. This lemon I'm dropping in the water. So did the size of the lemon increase, children? So obviously it's looking like as if it has bulged ante ubbatam. So that is like bulged in the water. Okay. So what is happening here? That is the phenomena what we are going to discuss. So why this pencil is bending? Why the pencil is bending? Now you can see the bending exactly you can see. And why this lemon has bulged. Okay, so all this phenomena, it is nothing but it is of because of refraction, children. I hope you can see the board clearly. Okay, so this is because of refraction. So now we are going to discuss about refraction of light on plane surface. Okay, plane surfaces. Refraction of light on plane surfaces. Actually, we have two children. Refraction of light on curved surfaces as well as on plane surfaces also we have. Okay, so now we are going to discuss only on plane surfaces refraction of light. So what is refraction first? So what happened actually when we have seen the activity, what happened to light? When we have seen this activity, when we have seen this small activity, what happened to light? Light has come, it has incident on this surface glass and it entered the water. Then it has incident on this, it has fallen on this pencil. So two times it is undergoing refraction. First of all, what is refraction? I will discuss. So first of all, refraction is nothing but when light enters two different mediums. When light enters two different mediums. Different medium. Okay. Two different medium it is entering. That two medium should be transparent medium, children. It should not be opaque or translucent like that. This all you have learned previously only. Transparent, translucent, opaque objects. All this you learned in previous classes only, children. So these two different medium light should enter. Light should enter two different medium, and then it should strike the thing. Okay. And when it enters the medium, what happens? Suppose a small example, children. Suppose we are walking on the road. We are able to walk on the road with certain speed. Is it possible to swim in water with the same speed? Is it possible? I mean, is it equally with what we are walking on the road, that speed, and when we are swimming in water, is that speed both same? No, it is not same. So in water, we have to struggle. We have to swim. We have to spend more energy. More energy we have to spend. So same thing will happen with the light also, children. Okay, same thing will happen with the light also. Light also should suffer, should spend more energy to pass through two different medium. Okay, so when it is passing through two different medium, what is happening? Okay, but before that, just I will explain on the board, then we will go for the pictures and all and show you. Okay. So suppose this is a glass slab. So glass slab A, B, C, D. And light is coming and it is incident on the surface AB. Here we will draw one imaginary light ray which is perpendicular to this surface. Okay, to this surface, that is AB, it is perpendicular. It is an imaginary light. It is exactly, or actually it doesn't exist, children. We are imagining it. Okay, so here one light ray say Q is incident on the surface. Actually, what should happen, children? Actually, what should happen? It should pass off like this. Because always light travels in straight line, rectilinear propagation. We already know that. Okay, so it should pass. I think it is not able to. But it's bending towards the normal. bending towards the normal. Light is bending towards the normal. Again here one more. Actually it should go like this, but it will bend away from the normal. Okay. Now here two different mediums. Say this is air and this is glass. Air and glass, two different medium. Air and glass. So both are transparent, we know that. So what is happening? It is bending towards the normal and away from the normal. Light is bending towards the normal and away from the normal. So as we have discussed, the speed of the light or the velocity of the light changes. We have taken a small example now, like walking on the road and swimming in water. Same way, same thing will happen to light also. When that happens, this bending takes place. When there is change in the velocity, this direction also changes. Why does it change the direction? Direction, why is it changed? That is because of very simple thing that you already learned, children. That is because of Fermat's principle. Fermat's principle. What is this Fermat's principle? Fermat's principle. What is this Fermat's principle? This Fermat's principle is nothing but, light always chooses the shortest path. Light always chooses the shortest path. So when it passes like this, it's covering more distance. But when it is bending towards the normal, that is shortest path it is choosing. So refraction, when refraction is taking place, two things are happening. One is speed of the light or velocity of the light is changing and it is bending towards the normal or away from the normal. Change in direction is taking place. Why change in direction is taking place means because of the Fermat's principle. I hope you understood what is refraction. Okay, now I will share the screen and you can see the actual thing. The screen you can see, children, refraction of light. Refraction of light. Okay, so you can see light is incident light ray and reflected light ray also there, and it is coming out, and which is coming out, that is the emergent light ray. So just you see here, children, this light ray is striking here, normal is there, which I have shown you on the board. Again it is coming towards the, towards the normal. Again it is going away from the normal. This is the normal here, children. So during refraction, light bends first on passing from air to glass and again on passing from glass to air. Okay, so refraction always is taking place because of the bending of light ray. Light ray is bending, that is only refraction. So when refraction is taking place, what is happening? The velocity is changed. Velocity is changed. So here, this is the glass slab, children. Actually, glass slab I have given on the board as A, B, C, D. Here you can see this is the glass slab. Ante gaaju palaka. Gaaju palaka ante palak slate kadu. It is 3-dimensional. It is having thickness also. Okay. So here you can see refraction occurs when light waves bends as they are passing from one medium to another, and causes of change in speed, wavelength, and direction. The frequency of the wave remains constant. Therefore, that you need not worry, children. It is not there for you. Need not worry about wavelength and frequency. It's only speed and direction you should take. And what is the speed of light in vacuum, children? So here you can see 3 into 10 to the power of 8 meter per second. That is designated with letter C, children. Letter C, it is designated. It is designated with letter C. C is equal to 3 into 10 to the power of 8, children. And what are the units? Meter per second. Okay. 3 into 10 to the power of 8 meter per second. That is the speed of light in vacuum. Speed of light in vacuum. What do you think? The speed of light in vacuum is more or in any medium is more? Vacuum lo ekku untunda, mana medium lo ekku untunda. It's nothing but in medium it is less, in vacuum only it is highest, because there is nothing, no material, no particles to obstruct light. So it is the highest velocity of the speed in vacuum, that is 3 into 10 to the power of 8 meter per second. Now, what are the causes of refraction we are going to see? So light travels at different speeds in different medium. So the causes of refraction is light travels at different speeds in different medium. It is possible for light to move as at top speed when particles get in the way. The particles in the medium slows down the passage of waves, which results in light traveling more slowly through a block of glass than through air. So I hope it is clear. What is the cause of refraction means? It is suffering. It has to spend more energy, or like when we walk on the road and when we swim in the water. When we swim in water, obviously we have to spend more energy than walking in the air. So same thing will happen for the light also. Light also suffers or will struggle to move through the various mediums, and it is easy for it to move through air and through vacuum. So one more slide, children. What causes refraction means? Refraction is the property of all the waves. Refraction occurs at the boundaries between two materials. Light refracts because it travels at different speeds in different medium. So this is the key point here, children. Light travels because light refracts because it travels at different speeds in different materials. So I hope it is clear what is refraction. Now, as you have understood about refraction, let us see actually what happens. I will share one image, I will share one picture, and then I'll explain, children. I hope this is clear. I hope this is clear. Now what I have drawn on the board, the same thing is there on the screen also, children. So here glass slab A, B, C, D is there. Glass slab A, B, C, D is there. And then one light ray PQ is coming and incident on the AB. What is meant by incident? Incident means coming from the source and touching a surface. The light which is coming from the source and touching a surface, that is called as incident ray. Now here PQ is the incident ray. Here PQ is the incident ray and it is entering the glass slab. That is, air is here, rarer medium and denser medium. That also I'll discuss, children. First you listen. What is meant by rarer and what is meant by denser. Okay. So what happens to the speed? What happens to the speed when it enters the glass? The speed gets reduced or speed will become less. So the medium in which the speed of the light reduces when compared to the other medium, then if the velocity is less than the other medium's velocity, in which medium velocity is less, that medium is called as denser medium, children. That medium is called as denser medium. I repeat, when the velocity of the light reduces when compared to or with respect to other medium, in which medium the velocity is less, that medium will be the denser medium. That medium will be the denser medium. And the other medium in which the velocity is high, that medium will be the rarer medium. So velocity is high, rarer medium. Velocity is less, denser medium. Now light is entering the denser medium. As light enters denser medium, it bends towards the normal and then it is traveling like this. Again, it is touching the surface CD and then it is coming out. Okay. It's coming out. And here it is making an angle, children. Here you can see, I'll rub off all this. You can see here. So angle E you can see here on the screen. Angle E is angle of emergence. Angle E is angle of emergence. Okay. So angle E is angle of emergence. Then here you can see actually the light will travel like this. Actually, light should travel in a straight line like this. But because of refraction, because the velocity is reduced, because it is changing its direction, it is bending towards the normal. Then here one more emergent light ray is there, parallel to the actual ray. So the distance between these two, the distance between the two parallel rays, that is called as lateral shift. That is called as lateral shift or distance. Lateral distance also you can call. You can call lateral distance or it is also called as lateral shift. Okay, here angle I is equal to angle E. Angle I is equal to angle E. And then you can see the thickness of the glass slab D. Okay. So I hope this is clear. I hope this is clear. Okay. 1 minute I'm giving you so that you can see this. Right. So what did we discuss now, children? Refraction we have discussed. We have discussed glass slab. Why refraction is taking place, we have discussed. Okay. Once we will recapitulate what we have discussed. We have discussed what we have discussed. We will recapitulate. Okay. Refraction takes place when light travels from one medium to another medium. That's the first thing what we have learned. Then refraction takes place. When it takes place, children, Of course, from one medium to another medium, what happens then? Velocity of light is changing, direction is changing, wavelength is changing. Wavelength means the distance between two consecutive crust or trough, children. Two consecutive crust or trough. And direction also changes. That means it is coming towards the normal or away from the normal. Why direction is changing means because of Fermat's principle. What is Fermat's principle? That is nothing but light always chooses the shortest distance. Okay, so this is about refraction, children. Refraction on plane mirrors, plane surfaces, sorry, plane surfaces. Okay. So I would like to share 2 questions, 2 to 3 questions, so that you can answer. Okay, so 3 only are there questions, children. What happens when a ray of light is incident normally on the rectangular glass slab? That means normally means what, children? What happens to the light ray when it is incident normally on a glass slab? Normally means what? So this is the glass slab. I have told you one perpendicular light ray on perpendicular light ray. Same way, if light enters, it won't undergo any refraction. It will pass, just it passes perpendicularly through that normal. So it won't undergo any refraction. Okay, so that is the first answer. First question answer. So what happens when ray of light passes from one medium to another medium having same refractive index? Then also light will not get refracted, children. No refraction takes place. Then what is lateral shift or lateral distance or displacement or lateral shift means? The distance between two parallel rays when light is entering a glass slab, and then what is the distance between two parallel rays? You can even draw the ray diagram which I have shared you before. I have shared, no, children. So that ray diagram you can draw it and show there what is the lateral shift or lateral displacement. Okay, I hope these 3 questions you can do it, children. I hope you can do these 3 questions. I hope the small topic refraction is clear for you. Okay, so okay, so it's a clear for, I hope so, children. Right, so first one in small like small summary, I'm going to just gist it for you so that you will remember. Okay, refraction takes place when light passes from one medium to another medium, and then light suffers refraction when it is passing from one medium to another medium. There is change in velocity, there is change in direction. Why direction changes means because of Fermat's principle. What is Fermat's principle? The light always chooses the shortest path to travel from one point to another point. And I have told you what is meant by angle of emergence and angle of incidence, and what is lateral shift, the distance between two parallel rays, light rays, when they are passing from one medium to another medium, that is called as lateral shift. Okay, I hope it is clear now. I hope it is clear. Ma'am Shailaja ma'am, you can stop record. Shailaja ma'am.
Yes, ma'am. Over. I'll end it.
Over, ma'am.